Okay, so what we're going to do today is we are going to discuss solutions. Whoops, there we go. Solutions of a linear equation. Okay, so first thing we need to know is what is a linear equation? So a linear equation is an algebraic equation in which each term has an exponent of 1, and the graphing of the equation results in a straight line. So the word linear means straight. So we're looking at an equation when graphed, it's going to equal a straight line. Now, what's different about equations now that we are in course 3 is that I have equations that have different types of solutions. Not every equation that we're going to come across has one solution. So we're going to take a look at the different types of equations and solutions we can have. Here's example 1. So I have 4x plus 3 times the quantity of 4x plus 7 is equal to 4 times the quantity of 7x plus 3 minus 3. Okay, so in order to get started here, I am going to look into my parentheses. When I look inside my parentheses, I determine, can I simplify this? The answer would be no. So the next step I would need to do is distribute, where I'm distributing this 3 into the parenthesis and this 4 into this parenthesis. So the next line would look like this. 4x plus 3 times 4x makes 12x, and 3 times 7 makes 21. Is equal to 4 times 7x makes 28x, 4 times 3 makes 12, minus 3. Now, anytime I have multiple variables or multiple constants on a side of my equation, the next thing I need to do is continue to simplify by adding like terms. So on this side, I have 4x and a 12x. That makes 16x plus 21 is equal to 28x, and then 12 minus 3 makes 9. From here, I need to get my variables all to one side in order to isolate them. So I'm going to subtract 16x, and I'm going to subtract 16x. 21 equals, this makes 12x plus 9. So minus 9 minus 9. This makes 12 equal to 12x, divide by 12, divide by 12, x equals 1. And then I would go ahead and I would box this. Then I need to obviously do a check to verify that this is correct. Oops, sorry, got a little crooked. So I'm going to rewrite the problem, substituting in. I'm going to run out of room, but that's okay. So we'll do our check here. Substituting in 1 for wherever x is. And remember, when we substitute into a parenthesis. So this would look like 4 times 1 plus 3 times 4 times 1 plus 7 is equal to 4 times 7 times 1 plus 3 minus 3. So I've substituted in all of my x variables, and now I start to simplify. So this makes 4 plus 3 times 4 times 1 is 4 plus 7 makes 11 is equal to 4 times 7 times 1 makes 7 plus 3 is 10 minus 3. This becomes 4 plus 33 is equal to 4 times 10 makes 40 minus 3. 4 plus 33 makes 37, and that's equal to 40 minus 3, which makes 37. Yep, that's the same. So now we finished and we solved this. This seems to be a regular equation. This seems to be something we're familiar with. This here is an example of a one solution equation. A one solution equation. So now we're going to take a look at another one. Okay, here's example 2. Okay, example 2 looks like this. 2 times x plus 1 is equal to 2x minus 3. So first thing I do is I look into my parenthesis. Can I simplify this? The answer would be no. So the next thing I need to do is distribute. I'm distributing this 2 into my parenthesis. So 2 times x makes 2x. 2 times 1 makes 2 is equal to 2x minus 3. Okay, so I'm going to go about solving this. I'm going to move all my variables over to one side. So I'm going to minus 2x and I'm going to subtract 2x. That leaves me with 2 is equal to negative 3. Is that a true statement? No, that's not true. Okay, well, I must have done something wrong. Maybe I should not move my variables first. Maybe we should move our constants first. So let's try it again, okay? So I have 2 times the quantity of x plus 1 is equal to 2x minus 3. Okay, distribute. So this makes 2x plus 2 is equal to 2x minus 3. Okay, I'm going to move my constants first to see if that changes anything. So I'm going to go ahead and I'm going to add 3. Now I have 2x plus 5 equals 2x. And I'm going to subtract 2x and subtract 2x. So now I have 5 equals 0. Well, that's not true either. So this is a special type of equation that is called a no solution. This is a no solution equation. It cannot be true. Okay. One of the ways we could see that is when we got to this second line here, and I have 2x plus 2 and 2x minus 3, because whatever I substitute in for x is going to be the same, right? So let's say I substitute in 0. Well, 2 times 0 is 0. 2 times 0 is 0. So it'd be 2 equals negative 3. Well, that doesn't work, right? Let's say I did 1 and I substitute in 1. So I'd have 2 plus 2. That made 4, and 2 minus 3, that makes negative 1. That doesn't work. So what we can see here is because, what do I call this thing out in front of this term? Does anyone remember?
Coefficient?
Yes, good job. Coefficient. So because this coefficient and this coefficient are the same, but then our constants are different, it's basically saying that this number and this number are always going to be the same, but then I'm adding or subtracting from it. How could that ever be equal? Okay, it can't. So that's a no solution. So what happens is we can start to see that pattern form. And when that's the case, then we can identify what type of solution it is. So let's try another one. This is example 3. Oh, other things. That is important. We do not do a check for a no solution. And we don't do a check for a no solution because there's no solution. So it's kind of silly to check if it's a solution or not because it doesn't work out to be a solution. Okay? So we never, ever, ever use a check with a no solution. We just know that it's a no solution. Okay, so here we go. Let's say I have 9 times the quantity of 4 minus 2x minus 3 is equal to 4 minus 6 times the quantity of 3x minus 5. Now, there's something happening on this problem that is the number one thing that gets everybody stumped. This is the number one error. This here. Okay? We have to remember that the sign goes with the term. So because this is a 6, this is actually a negative 6. The sign in front goes with this term. Okay, so if you don't pay attention to that and you don't distribute with this sign, it's going to make a big difference in your problem. We're going to come back here. I cannot simplify within my parentheses. So I know I'm going to distribute here, and then I know I'm distributing here. So you have 9 times 4, which makes 36. And then 9 times negative 2x, which makes a negative 18x. Minus 3 is equal to 4. And I have a negative 6 times 3x, which makes a negative 18x. And then over here, I have a negative 6 times negative 5, which makes a positive 30. Is anybody starting to notice anything? I see a lot of blank stares. That's okay. Okay, we're going to keep solving then. So now I'm going to combine like terms. So I have a negative 18x plus 33 is equal to a negative 18x plus 34. Okay, have we noticed something yet?
Yes.
What?
That my negative 18x is on both sides.
Okay, so they have the same coefficient. And then what else do we notice? Do they have the same constants?
Yes.
They do?
No.
They do not. So this party over here is having 33 people attend, and this party over here is having 34 people attend. Is that the same number of people at each party?
No.
No. So when we look at this, now I'm going to get my variables all to one side. I'm left with 33 is equal to 34. Is that a true statement? Absolutely not. No. So this right here is a no solution. So when we solve a no solution equation, you're going to box the words no solution. Okay? If I was solving an equation that had one solution, like x equals 3, then I would box x equals 3. Okay? That there is what we are taking a look at. So we covered no solution and one solution equations today. And that's what we are going to work on.